So Operations Insight is one of the services within observability. This service provides deep and meaningful insights into your operations. The primary features here are the capacity planning and the warehousing. In terms of capacity planning, we can analyze the resource usages. We can see the trends for the databases and the hosts, and can also forecast the resource usage in months and weeks to come. So this gives us a good idea of the impending issues that would come in the future. For example, now we are coming through a holiday period where for many of the customers this will be a peak period in terms of user traffic, and that will put a huge load on the existing resources. Operations Insight can tell you in advance when the database or the host would get heavily loaded or run out of resources, all thanks to various machine learning algorithms that work in the background. This advanced insight not only keeps us alert on the resource usages, but also help us with the budgeting and potentially avoiding downtimes due to resource shortages. In terms of the warehousing, the SQL Warehouse is a long-term warehouse storing details of all your SQL queries from all your databases in one place. This allows you to perform historical analysis on these queries as the need arises. But more importantly, this service out of the box tells you which of these queries are degrading in nature, highly inefficient, highly variable, or have too many frequent plan changes, things that could impact the performance of these queries. Similarly, it also provides warehousing for the other parts in OCI. For example, we have the warehousing for our Accelerator resources, for the enterprise manager telemetry, and it also acts as a long-term AWR snapshot hub. We talked about logging analytics as well, which is a very powerful service which can ingest any kind of readable logs from across your IT infrastructure. And it provides valuable insights through analytics and dashboarding methods. Oracle can ingest over 250 different kinds of logs out of the box. And if there are any custom or proprietary logs that you want to monitor, it can be done from the UI itself in a matter of minutes. The Log Explorer provides various visualization methods that help in providing insights out of the raw data that have been collected. Further, if you're stuck in a P1 or a P2 scenario where time is of essence, we can take help of the machine learning to find out the probable root causes in a matter of few clicks. This service also serves as a long-term log retention for low cost that would help provide historical analytics over the past months and years. Now we will continue to the demo. I will share my browser. Just one moment. So here we have the Oracle Cloud homepage. On the top left here, this is the main menu, or the hamburger menu as we call it. Over here, we see observability and management, under which we have the services, logging analytics, and operations insight. Let us go to operations insight first. So here I have selected the relevant compartment. I have selected the correct region where my data lies. And now here we can see that we have 55 databases, 7 hosts, and now on the left-hand side, we see further insights into these. So in terms of capacity planning, so you see here, we have capacity planning for the databases, and then we have capacity planning for the hosts. For databases, these are the metrics over which we see the insights. And again, for hosts, there are a couple of them, which we will see in a few moments. In terms of databases, as you can see, we are looking at the time range of last 30 days. And we can see here in the first part where we see different type of databases by the platform. Some of them are external PDB, some of them are ADW, ATP, and so on. If you want to view them by version, whether you want to view by telemetry, we can filter them out this way. For the CPU, we see here, for example, so in this case, for CPU, we have almost negative 5.26%. So that's a decrease in usage of CPU, overall aggregate CPU over the last month. In storage, an increase in 30%. For memory, an increase in 44%. And IO is negligible, almost the same. And then we come to the CPU insights. So on the left-hand side, we see the CPU insights, the storage insights, the memory insights. So these are the three main ones. We'll discuss this in a few moments. On the right hand side, we see the trends of the CPU, and then we see the top CPU consumers based on these metrics that you select. Similarly, you see the trends for the storage and the top consumers for storage, and then again for memory and the trends for the memory. This gives you a very quick insight into how these resources have been performing in the given selected period. What's more important is the insights that we see here. So currently, it tells us that out of the 54 databases that we have here, 5 of the databases are currently highly utilized. So the CPU usages are above 75%. In this case, 14 of the databases are underutilized, which is less than 25%. Now, in a real scenario, we would like to have an optimal utilization. We don't want highly utilized systems, neither do we want underutilized systems. In this case, we see this is the true insight which helps us with the capacity planning, because it tells us in the next 1 month, 11 of my databases will reach a state of high utilization. 16 of them will turn out to be underutilized. So we click on this to see more info. Now it opens a new page where we see more insights into these. So these are the database display names. We see the types of databases, the current average active CPU usages, how much total CPU has been allocated, in this case 64 CPUs, the current utilization, which is around 80%, and in the given period, which is last 30 days, we see there's a change of almost 49% increase. If we look down here, this is the trend. So left to this vertical line, this is the actual trend based on the metrics we have selected. And we see the average active CPU. And to the right, it shows us a calculated trend, which tells us automatically that on this particular day, which is November 17, our database is likely going to overcome the threshold, which is the 64 CPUs. So as of now, it's somewhere around 54, but on this day, it will cross that threshold. So we know that this is the approximate date on which it is going to consume more than what is allocated. Now, being a manager, being an architect, your resource guy, anyone, you have this advanced information and you can allocate extra CPU so that the system doesn't stop, doesn't slow down, and your application doesn't fail. Now, if you select the machine learning, this further takes into account the seasonality. Since it stores metrics for a long time, depending on the seasonality, it is able to predict further how the trend will be. And this is the confidence channel that these resources will be somewhere along this line. Now, this gives us a very quick insight into how the systems will behave. Now, similarly, we have similar insights for your storages. So you can see you will have similar insights for the storages, for memory, IO, and then when it comes to the hosts, we have similarly for the CPU and the memory. These are the important ones that we consider. So you will have similar insights where the utilization says that 7 of my hosts will be underutilized, and it will provide a graph similarly, and we can perform capacity planning in advance, thereby preventing any kind of resource problems, preventing possible downtimes, and of course, it helps us in advanced budgeting as well. Now, if you have Exadata, then in that case, let me select the appropriate compartment showing Exadata. So for Exadata systems, we see similar insights. In this case, you see this is a quarter rack, and it has already breached the utilization levels in terms of CPU. For this one, another quarter rack, we see that in the next 16 days, the CPU will get breached. If you want to take a look into the details, further clicking inside, it shows you in terms of the visualization, which are the components of your Exadata, and then you can further see the metrics by the database, by the host, and by the storage server itself. And you see these kind of useful insights in advance. Now, coming back to operations insight again, on the main menu, we have these warehouses. Now, let us quickly take a look at the SQL Warehouse, which we talked earlier in the presentation. Going back to my compartment for operations insight. So we have 54 databases, as we saw earlier. And for the given time range, we see that so many, around 3,000 SQL queries have been analyzed. Machine learning out of the box tells us 20 of the SQL queries are showing degradation in nature. There are none which are variable, which is very good. We wouldn't want queries to be highly variable. Consistency is the key, of course. In terms of inefficiency, there are 9 inefficient ones. There are some with frequent plan changes. Some of them might require improvement. Some of them have degradation as well as plan changes and so on. In a sense, out of the box, machine learning is showing you which of these queries might impact the performance of your application. So once we click on the inefficiency, because I'm interested in looking at that one, I see that this is grouped by the databases. So under this particular database, we see that this particular selected SQL query is showing a very big change in the response times and the inefficiency. The size denotes the average response times, which is quite big, 16 minutes over here. And then the color coding tells us in terms of percentage, the inefficiency of this particular SQL query. So in this case, we see it's almost 89%. That's why it's deep red. We see the trend over the last 7 days. And then if you want to see more insights, we click on this, which opens a summary page showing more performance stats for this particular SQL query. Now here we see the performance trends. We see the activity. So this particular query was showing to be inefficient. And here we can clearly see that the CPU and the IO levels are consistent, thereby they are not the reason for the inefficiency. It has a lot of inefficiency bits. Now, inefficient bits could be due to various reasons. We could look at the other services within observability and find out what really is going on. Maybe there are too many plan changes. Maybe there are too many frequent log data switches. There could be a variety of reasons. In terms of other metrics, we see the response times. We see depending on the breakdown based on the plans, if it is across multiple plans, across multiple databases. If you want to see a comparison, if the SQL query is running on multiple plans, you see these metrics across these selected metrics. Similarly, instead of plan, you can select the databases if the query is running on multiple databases. Now, coming back to Operations Insight main menu again. So we have similar warehousing for your enterprise manager telemetry. We have it for the Exadata metrics as well. And then also for the AWR hub, which is nothing but it's a long-term hub which stores your AWR snapshots into a single space for your historical analysis. Now, together with all of these things that we saw here, we can easily create custom dashboards suiting our needs. They are very easy to create, and the visualization actually helps us to identify the performance and the usages of our system.